So today I'm gonna play Turing Complete. I'm working on the graph visualization stuff off stream. Maybe I will continue to work on it on stream, but at another time. I think it's better to try to do that off stream because it's easier to use two monitors at the same time when you're doing stuff like that. And the part that I got stuck before, when I was trying to do this off stream, was I'm trying to change the functions so that I can move around the nodes with the keyboard. And I think that's gonna take knowing some JavaScript, and yeah. So it's gonna be a lot harder than I thought, but I think it is a very useful thing, so I'm gonna try to do it. Because I'm probably gonna learn a lot in the process about investigating JavaScript and seeing how to interact with Python, how to integrate Python and JavaScript. So I was looking at those videos. So I'll probably continue that another time. I think I'm gonna spend 2 hours here doing this game. This is a game that I believe Vivex told me, and I saw some people doing on YouTube, so I don't think there's a problem with doing it. So pretty much from what I understood, you build circuits, and then eventually you build your own computer, and you do this by doing logic gates on this platform here. With a functional computer, you'll be. And people say that this is very hard for people that don't have a lot of understanding. So I imagine I will spend a lot of hours trying to figure this out. But I think it will be very good because it will increase my understanding of how computers think. And I like the layout. It's probably a lot better than just watching videos to do this. Signal flows from the in component to the out component. In the upper left corner, under input, there is a green icon. Click on it to turn the in component off. So I guess it's this one. Notice the out component is turned off. This is because the signal stops flowing from the in component. So when you click, it stops the signal. Very impressed with how well we completed the last task. We have decided you're probably not a plant. In this level, the challenge is to figure out how the NAND component works. Be sure to figure it out before I complete this level, or you'll get stuck next level. So NAND, if I'm not mistaken, is not AND. So what does the AND gate do? I'm not sure what clicking on this does. Oh, I'm not sure if I can click on this. The NAND component in the middle changes the flow of the circuit. Use the bar on the left to experiment with the inputs, see how they affect the output, and fill in the last row of the table. So I need to turn this on, I think. Yeah. So when they're both on, the output is off. When one of the inputs is off, the output is on. When they're both, so it's only off when they're both on. That's what it does. Yeah. Now it's off. So neither of them, both of them have to be on to the, what have I done? I don't know what I clicked here. Let's change the screen. Oh, I can scroll to change the size of the screen, apparently. But I'm not sure how can I move this somewhere. Like color to wire, right pipe, back branch wire cluster. Also, it's AWSD. Space rotate, select all. Right arrow. Okay, so yeah, so this is AWSD to change the thing. And then I can zoom in with the scroll on the mouse. So when both of them are on, this is off. Just trying to make sure take some time into this on this challenge to make sure that I really understand, because I know it's gonna get more complex later. And if I don't really understand what's going on, then I'm just gonna stack the mistakes, which is gonna make me be stuck on future challenges. So not end. So it's probably the reverse of the end. And the end works when they both on its own, and then when they both have to be correct to be on. And this is the reverse, which it means that they both have to be off. They both have to be on, so it's off. That makes sense. Now I believe I click here. Oh, I have to. Oh, I can click again. I have to make the truth table here. So when they're both on, it's off, and otherwise. Have unlocked the NAND gate. With this component, you can build everything else in your computer. Onwards. Now that you unlocked the NAND gate, it is time for you to build a circuit. Last level we made a table that described the circuit. This level will be the circuit that matches the table. Using NAND gates, build a NOT gate. Using NAND gate, build NOT gate. So this is the truth table I have to reach, I guess. Now I'm not sure. Next tick, run ticks. What is select? How do I have an AND gate here? As I can drag here. Unless both inputs are, then it's on. Select the component by clicking the background. And, so I can click and drag and it makes a connection. Build a circuit that makes the table correct. Click next tick in the upper left corner to test each combination of inputs. You win the level once both combinations have been tested corrected. So this test one. Yeah, so this makes the test, the current flow, I guess. So now I'm testing when the input is off. Zero output, current output is out. And then I have to test when the input is on. And when the input is on, it should be off. So yeah, now it's just a normal NAND gate. Can I put more? Oh, yeah, so that makes sense. Otherwise, it's probably impossible to do it. So when it's off, so how can I do this? Let me think. First, let me see. Oh, if I press the right thing on the mouse, then it removes them. So let me think. So the input is off. It should be on. Damn, this is already difficult. Trying to think, because the NAND gate, when both of them are on, it's off. Otherwise, but that's when it is connected on both things. So I have to build a NOT gate. When it's on, it's off. When it's off, it's on. Maybe if I put this here, this here. Yeah, so now it's passing through this one to activate. Because when I put, maybe this is correct already. Let's see. Oh, run ticks. Nice. But I don't understand what I did there really well. So let me think again. It's kind of hard, breaks my head. So the NAND is when neither of them are on. When both are on, it's off. Mm, if only one of them is on, then it's gonna be on. But I don't understand why it's on here if this is off. How is the input coming from here? I guess that's the part I'm confused about. Because if the input is off, where is the flow coming from of the circuit? That's what I don't understand really well. The circuit that makes the correct table, gymnastic, the left corner. Let's see, I can change the output. Oh, when I click here, it changes the screen. That's why I did this that time. So now I can just do this, change again. So this is the test, and this just runs the next tick, which is the next thing here. I think I'm gonna go to the other one because this probably doesn't explain why one is on. But let me see if I understand. I think I understand now. And besides this point that this is on when this is off, and I don't understand how this works. I think the reason why this works is because when both inputs of the NAND gate are on, then it's off. And when you turn this on, because it's not going through, when it's off, it's only going through this one, it's gonna be off. But when you turn this on, it's gonna pass through both of them, which is gonna make this NAND gate be off because both inputs are on. And that's why it works. Yeah, because now I have the current going through both of them. But I think I can even erase this, maybe. But now it doesn't work. Oh, it does work. Yeah, so the other one wasn't necessary. I guess that this is just a representation on real scenarios. It might be coming from another connection to this NAND gate, perhaps. So let's go to the next one. This keyboard Japan, complete available, locked. Okay, so yes. Oh, this was the one that I did already. And then I can click on either one of them, I guess. Most creatures on Earth are aggressive and do not know how to concentrate. To succeed in this level test, in this next test, you have to learn how to place components in circuitry while not destroying the test equipment. So I'm not sure what they want me to do. I guess you have to achieve this truth table here again using these gates here. So this is the NOT gate, this is the NAND gate. So when both are off, so I need an OR gate, I think. An XOR, maybe. No, XOR would be it wouldn't be this end here at the end. So when they both are on, it's off. They both have to be off in order to be on. But this is just an AND gate, I think. Let's see. Okay. So this didn't work. I don't understand why it doesn't work. So when this is on this, also each input is represented by this thing here. But I thought the NAND gate was supposed to do this. No, so I guess it's not. The NAND gate is just when they're both on, it's off, but the other ones. No, when they're both off, it's on. And the other ones is just on. So obviously I'm gonna need to use this one as well. Because it passes the first test. So it means that the NAND gate is gonna be off. It's gonna be on for the other outputs. It doesn't make sense based on the previous challenge. Maybe I have to go back and see if I really got what an NAND gate does. Yeah, but I thought that both of them being on it means that it is off. Oh yeah, I'm just confused about which ones. When both of them are on, this is off, and all the other scenarios, the NAND gate's gonna be on. So I need to put this somehow here. Let's see if I can do this. How can I test? Just I can put it in here. Yeah, so now it's more interesting. Yeah, but this should be off, not on. It's still on because this is on. So what does the not do again? The not is the inverse. So whenever I want to inverse first something, yeah, it goes through the not. So the first one's gonna work with the not, but oh, maybe I can use more than one. Can we use more than one on each one? So I can make it. Yeah, but the thing is, when they're both on, yeah, it should be off. Damn, this is difficult. Because if I change anything, it's gonna change the other ones. So when they're both off, this has to be on. But here it doesn't show that it's on. Oh, okay. So it only turns on after you activate both of them. So it has something going through them, through it. So now, I wish I could change this after I made it. It's annoying that I can't move around the thing. So now let me think about the R. So the R needs to inverse the NAND gate, I guess. Let me just do this. Let's see what happens. I turn this on. I break this first. When they're both off is off. When one of them is on, is on. Only when the right one. Oh, because yeah, obviously this is for these ones. So this is the same input for both of them. So when both of them are off, it's off. When one of them is on, it's on. That's not what I want. This should be off. And this should be off when this is it's on. When the input is on. maybe if I take the NAND gate out, just connect. If I take the NOT gate out, so now it's off. Now it's on. They're both off, it's on. They're both on, it's off. Yeah, but this is working because it should be off in this situation. But I want this situation to be off as well, and it's on. So let me try like this again. I'll test for this one at a time so it's easier. Yeah, so now it's off. And when both of them are off, it's still off. So let me try to get the first one first. How can I change this thing? So annoying. So I don't know what these things do as well. Yeah, but now let me turn them on again. Yeah, now it's on. And they're both off. But I'm not sure if it passes the thing. It passes this. It doesn't pass this. Oh, it did pass? Oh, it passes the first shoe. And then it stops on the third one. Which is this situation here. And this should be off as well. So that's the problem. Maybe the whole way I'm thinking is off. And I should connect like I did the other way. The other one. Where I connect this output to this one. So this is the situation I want it to be off. There we go. No, now it's still on. The problem is that every time I put something, it becomes like the test is different than when I'm building the thing. So maybe I can try to do. Yeah, I have to understand what's going on. It's better than just trying to do a bunch of variations. See if I get it correct. So the NAND is when either are off, when both are on, it's off. Otherwise, it's gonna be on. You don't want to negate that on these situations with either or. So just the NAND gate is gonna be passing the first task. But then it fails the other one. Yeah, so it's the other way around. Yeah, no, it's correct. When both of them are wrong, are on, then it's off. I wonder how can I test. Oh, I can just do this. Change. Both of them are on, it's off. And on the other situations, it's on. Let me see what the not gate does again. So one of them is on, both are on, it's off. Forgot to put this one. So when both are on, it's off. And either one is on, it's off. Also, this is the one that I need for the middle there. The NAND gate for the alternation. And then, yes, so I'm not sure if I can do, probably not. Because if I do this, it's gonna change the other ones. Did I pass everything? Nice. But I still, it's hard because even though I'm passing, I'm not sure if I'm understanding the logic very well. Because it's very confusing. I'm also with a little bit of headache from the dopamine detox stuff, which is not a full dopamine detox because I'm still gonna go for a run. I'm still eating bread and things like that. But it is a detox from sugar at least. Sugar and entertainment and music, that kind of stuff. So usually when your brain is used to this stimulus and you take it off, you're gonna feel pain because uh, the living animals inside of your brain are used to the stimulus. I probably not sure if that's accurate at all, but yeah, that's how I think about it. So when both of them are off, this is on because it's already charged there. This is the hardest part to understand so far. Like, how is it possible for both of them to be charged when the inputs are off? I just don't understand it. And this, for some reason, is working because I'm not really sure. Because if it was just an end, it was supposed to be on. Yeah, if it's just an end, it's supposed to be on. Because it has a not, then it becomes off, I guess. But probably this way that I'm doing, I'm not sure if it's the best way as well. Because there might be another solution to this that's way better than doing the way that I'm doing. Oh, this is the level map. How can I go back? Switch schematic, level log. I wish they had the answer. Okay, so this is the log. Also, I can save the schematics here. Each one that I do. So maybe I do another one here. This is shredded. Copy. And now I changed. So I think I'm gonna try to do it another way to see if it works. This is gonna be equal to the other one. The output of a component leads back to its own input. Read more. Circular dependency is when the input of a component changes based on its own input. You know? This game does not allow circular dependencies and instead triggers an error. The exception to this are the square pins that do not influence the output in the same tick. They can therefore not cause circular dependence. So because it's going here and then affecting the input, doesn't work. Oh, I guess I did the wrong way here. Oh, this, yeah. Now it's correct. But now this is gonna work as a NOT gate. It doesn't work now. Because the NAND gate already has a current going there, which makes the input on. So both of them, if either one of them is on, it has to be false. Which means I can't use the NAND gate for that. The NAND gate is only useful for this one and this one. And both of them are off. So they both have to be off in order for it to be on. And the outputs is only one on. Yeah, so I have to transform this NAND gate, which solves the first one. This solves the first one. I have to transform this into a NOT gate. Well, that doesn't make sense. Yeah, I don't see any other way to do it than the way that I did there. Because it only has to be the NOT gate when this with these inputs when either one is on. Yeah, on both of them on it's gonna be off. So I have to transform the NOT gates, but only either or. Maybe if I make a uh, NOT gate here and connect like this. Yeah, but now it's on when both of them are on. because it's gonna reverse the output of the NAND gate. And the issue is if I connect one of them to the output directly, then it is not gonna work when I'm testing for the other one. Yeah, now it just changes the NAND gate. Maybe if I did it like this. Yeah, it's on the first, but I want to test this one. So this is correct. This is still incorrect. That doesn't work. And this input seems to be off as well. I'm not sure if this works. Yeah, doesn't work. I don't see a different solution. Not sure if it's worth it to spend more time here trying to think. The biggest issue is that I'm not sure if there is another way to do this, or the way that I'm doing is the right way. Because it feels a little bit tacky the way that I did it there. So the NANDs when both are on, then is off, and otherwise is on. The NOT is just the reverse. Let me see. Let me remember what the NOT gate does. So when both are off, it's off. And either one is on, it's off. And when both are on, it's off. So it's only the last case that the NOT gate doesn't work. And you need the NAND gate. So if I attach this to this, and now it seems to be working. So I'm not sure if this is the solution of the other one. Let me compare. Yeah, I think it's the same solution. Just slightly different way that I did it, but the same. Yeah, so I think I'm gonna move on because I can't think of any other way to do this. Guys, I got to go here. Onwards. Should be happy you get to participate in your glorious tests. You get a chance to communicate with very advanced people from the galactic civilization. So now when both of them are off, that should be off. Yeah, and every other option that should be on. So it's pretty much the reverse of the NAND gate. It should be like this. I'm not sure. Maybe it's the other way around. No, it works. And this one is an easy one. So I guess I'm gonna do it the other way around to see if it works as well. It probably does, and it's probably better, I guess. But I think I'm already getting slightly better at understanding what each gate does than I was before. So this way it doesn't work. It has to be the other way around. Yeah, because this makes the not gate only. This one should discourage you, but I think the elephant will win the competition. No offense, but your brain is tiny in comparison. It's dissing me, but I'll do this stuff. Create a secret that matches the table. Deep double click a component should also select its pin. The matches. Oh, I forgot the double click a component should also select its pin. Don't understand what this means. Oh, I think I get it. So this one, all of them are off, when both of them are on. So this is an AND gate, probably. Both have to be true in order to the output bit should be true. And the NAND gate is the inverse. So it's like the other one, pretty much. It has to be false. What's the difference between this one and the other one that I did just now? Yeah, this doesn't work. Yeah, the other one was all true, except this one. And this one is all false, except this. So I know the NOT gate's gonna work for the first three, I guess. No, when both of them are on, it's on, not off. Yeah, this has to be the NAND gate. The NOT gate makes it be false on all the other ones. The AND gate's false. It's true unless both of them are true. And so far, I haven't used true NAND gates as well. So maybe I'll have to use it on this one. So NAND, when both of them are off, it's on. Yeah. Let me see it again. Yeah, both are off, it's on. They both have to be on, so it's off. Which is the opposite behavior that I want. So I want the opposite of an AND gate, which is the AND gate, not AND gate. Probably like this. There we go. So it's just like the other exercise that I did, but it's the other order. Yeah, this says here AND gate. So I'm gonna go, oh, this is the OR gate. So the OR gate is the beginning. When the NOT gate is before the NAND gate, it becomes an OR gate. And when the NOT gate comes after the NAND gate, it becomes an AND gate. Because it reverses the output of the NAND gate. Yeah, this one is the more difficult one for me to understand on a conceptual level, let's say. Because the other one is easy, it's just the reverse because it's a NOT gate. It's gonna reverse the output of the NAND gate. But this one, because the NOT comes first, I guess I don't really understand what the NOT is. Yeah, NOT is an OR gate, maybe? What's the difference between NOT and OR? I guess. Yeah, I'm not sure. The input is off, the output is on, the input is off. When the input is on, the output is off. What's the difference between this and the OR gate? I know it doesn't work if I do it like this. Also, that's probably the difference. The NOT gate, when both are off, it's on. And then it's off. In the other situations. So the NOT, they both have to be off in order for the output to be on. Both inputs have to be off for the output to be on. And the OR gate when both inputs are off is off and that everything else is on. So the NOT, both inputs have to be off in order to the output should be off. Both inputs have to be off in order for the output to be off. The NAND is probably the reverse as well. When both inputs are on, it's off. Everything else, it's on. And this is getting confusing. It's gonna take me some time until I really get used to this and understand. Even though it's so simple, when you look at the logic, the truth tables, it just gets confusing to make sense of it when you start adding uh, the gates. Create a circuit that is always on. So that should be on all the time. Oh, they didn't explain what's an OR gate. And neither input is. Well, I guess I solved in the previous challenge without knowing the name. So when either input is on, then it's on. And it's when both inputs are off, it's on. Other situation is off. The R, either R has to be on. And when they both are off, it's off. So I guess I can use a R and then end here. No, this doesn't work because when they're both off, I want it to be on. So that should be an AND gate. This is gonna pass the first one and fail the other one. And here, it probably works. There we go. Yeah, it's I don't know. It's difficult to remember which one is which and how it works. But solving it is not that hard, I guess. As you know, this task culminates in building a functioning computer. Species that are capable of finishing are considered sentient by law. This is the main reason we don't eat you afterwards. Output on second tick only. So that should be on only when one of them is on. Gates, misc. What is misc? Always on. Also useful as byte 1. I don't understand this. So far this is the biggest issue that I'm having with this game is that they don't explain this stuff that they put here. It seems like they put out of nowhere. but it's just this one. The other ones will have the explanation, and they come from previous challenges. But there was another thing that I think they did here about an explanation. But overall, it's a good, really good game so far. So now let me think how I can do this. So the end, they both have to be on in order to input should be on, and everything else is gonna give me false. The NAND, when both are on, it's false. Everything else is correct. So the end is probably not really useful here. Oh, it's useful for the last output, I guess. Yeah, the NAND is useful for the last, and the end is useful for the first. You can use an OR gate for the first one. The issue is the ones outside, I guess. In the middle, I can use an OR gate. Yeah, but this should be off. Should be only on with this one. So I guess I can change here. And now it's off. And now it's on. But when both of them are off, it should be off as well. Both of them are on, it should be off. And it's not. So I guess here the NOR gate works really well for all pretty much all the inputs. If I do it like this. Yeah, now it's on. Except the last one. So it's gonna be on, and here is gonna be off. The last one, when both of them are off, are on, that should be off. So I guess I can use this one. But then I'm not sure if it's gonna affect the other. Yes, it does affect the other ones. I'm not sure if I can do this. Let's see. The NAND gate is only useful for the last output. Now is the problem. So the question is, how can I negate the fact? I can use this not here. See if this works. Alt click and move. Don't you read what's alt click to move where I had? Don't understand there, but so when both of them are on, I want it to negate this. Yeah, but this doesn't work. Maybe if I put here. Yeah, the problem is the R is gonna activate when both of them are off. Oh, this is one of the challenges I solved as well, I think. It's just a different name for the gates. It was the last challenge I solved, probably. So I'm not sure on this one. Maybe I can't use the R to solve this. Oh, maybe I can use a NAND gate first, and then attach the NAND gate to the OR gate. Oh, the NAND gate is the other way around. It's the AND gate. So the AND gate first. And then when this output is on, it has to be on. So I can make an OR gate here. I'm not sure if this is gonna work. So far, so good. Then the last one is gonna be a problem. Because when they are both on, it has to be off. But at least it's passing all the other ones. So let me think about this. They're both on, it has to be off. Which means it's an AND gate. So when they both on, it has to be. I have to put the NOT gate here somehow. I'm not sure if I can connect all of them to the output directly. That's the problem. Or if it has to go through the. Maybe I connect the OR to this output here. Like this. Ooh. So when they're both on, it's on. When they're both off, it's off. Not when they're both on, it should be off. So the problem is that this one is turning the zone on this one. Then if I make it, yeah, but I'm not sure how can I make it so when this zone is on, then it comes off. Maybe if I do like this. Yeah, now it doesn't work. Because this is turning the zone when it shouldn't be. Well, yeah. If I put both of them, same thing. Yeah, the issue is that this one is gonna activate. It's gonna activate the input on this one. So this might not be the best way to go about it. Maybe I can put a NOT gate here, then attach to here, and then attach to here. If that's gonna work. Both of them are off now. It's on, so it doesn't work. Maybe if I do it the other way around, touch this one here. So this doesn't work. Yeah, I have to put another input outside the end. I think it has to be the end in first, because it's the only one that has false. Oh, there are also tests false when both of them are false. So I guess it can be the R first. It's gonna pass the first two, and then it fails on this one. Oh, this is the exclusive OR gate. Either one of them has to be. Maybe this is the exclusive. The XOR gate, I'm not really sure. So I know this input needs to be off. What if I do it like this? Yeah, but then it's gonna always gonna be off. Oh, apparently not. But the current is going this way. So maybe if I do it with both of them, it's still on. Yeah, so it should be like this probably. Well, now it's on again. It's the other way around. So this passes all of them except the last one. I think at least this is the right direction to go. I want both of them are on. I want it to be off. So I wanted to act like an end gate on this one, OR gate on this one, then NAND gate on this the last one. Yeah, the only one that acts as OR is this one. Oh, there's also. Yep, this is not what I want. And this is breaking my head. I think I'm gonna have to take a break soon. I definitely won't look at a solution until I figure out how to do it. Because otherwise defeats the purpose of doing this in the first place. It's just that I'm kind of stuck. I can't think about any other way to do this. Also, this one also works. So maybe I can put an AND gate here. Yeah, but then the problem is gonna affect all the other outcomes. Probably. Yeah. So maybe if I put it like this. But this is still on. The issue is that it has to negate the output of the OR gate when both of them are on, but only when the both of them are on. That's the problem. Maybe if I start from scratch. I think I'm gonna start from scratch and do it from right to left first. See if it's better. Yeah, so this is only off when both of them are on. So maybe if I put this on an OR gate, but then it doesn't work. This is only gonna fire off if it both of them are on. So if I do this, it's the other way around. Yeah, but this is the way that I was doing before. And it fails on the last one. So the question is, how can I negate the output when this one is on as well? Like I have to negate the effect of this one, and both of them are on. Oh, this is not even connected. I think it has to do something. That should be something with this NAND gate here. Yeah. So this doesn't work. Maybe if I do it this, then this on the NAND gate, like this. The issue is, I think if I'm doing like this, it's probably not gonna work because the AND gate's activated. It has to be connected to both of them in the beginning, so it's false. But then I can't turn it on. I can make it false when they're both connected. If I'm using the AND gate to connect them, connect both of them. So I think I need another way to make the first value false. When both of them are false, that should be false. But if I use a R here, it's just gonna be an R gate. Maybe I can use the not one in the beginning. I think if we can make the first logic work, then the last one becomes a lot easier. Maybe if I connect this to here. Yeah, there we go. Now it's closer. List. So now I need an AND gate. Because when I activate both, I need it to be off. But when I do this, it becomes on because it goes through the OR gate. Let's see if I connect both of this. It's gonna work. No, it's still on. It doesn't matter because it's going through here first. So I need to figure out a way to negate the effect that this has. But only when they both are on. That's the problem. Because then I screw up the first one if I do that. I think it has to be something to do with the NAND because this is the only one that turns off. Oh, this NAR also turns off. So it's either NAND or NAR for the last thing. It's on when either input is on. So I need to make this false for the first one. So if I connect to both, it's gonna be on the first one and it's gonna give me an error. And if I connect it to the last, it's gonna be on anyway because So maybe if I do it like this, it doesn't work. Yeah, I can connect this to the output. I'm gonna connect it through here. And this is probably not, oops, this is probably not gonna work as well. Yeah, but it fails on the first one. This is going through the NAR gate. Well, I don't think it was connected, the previous one. Yeah, I can't use this directly in there. Oh, and this doesn't work as well. It was only working because it wasn't connected properly. Yeah, so only with this R, it already works here. It's just the next one that I have to think about. Or maybe if I do the NAND gate, but then it's gonna activate the other ones. This is definitely not gonna work. Maybe I connect this NAND gate to an AND gate. Yeah, but that doesn't make sense. Let's see if this turns it off. Hmm. Does this solve the thing? No. So the issue here is that's getting me the own output, the first one. So maybe if I use the end here, yeah, but then I get into the same problem because it's gonna go through here anyway. So maybe if I use the not, yeah, but then it's gonna change the NAND gate. And if I put directly in the output, it's not gonna change anything. There we go. Nice. Finally. Damn, this was difficult. Yeah, there are probably other solutions as well. You know, don't necessarily feel like I understand how it works. I think I'm gonna take a break before I continue this. You know, I'm ready and I'm still on the basic logic stuff. Last level, we built a circuit that was on when we were at the second tick. That will be the circuit that is on when we are at the second or third tick. This is also known as an XOR gate. Now is the XOR gate. This level is difficult, so don't be discouraged if you don't get the answer right away. The other levels were difficult as well. So it's either or. I've seen some stuff about this, but I don't remember really well. I just remember the truth table, but not how it was built. I think he uses the R and the AND gate. So this one is failing. Yeah, now it fails on the last one. It's probably very similar to the previous one. So both of them are on niche BR. So turn this one. You should make it off. Maybe if I connect them both to an AND gate. but then it's gonna fail on the first one because it's gonna be on. Yeah. What if I do this? It's still on. Also, this NOR gate also works for making it off when they're both are when both of them are on. So I want it to work as a NOR gate first and OR gate. Then the last one is the problem. If I have two OR gates connected to an AND gate. Yeah, doesn't feel like it's gonna work. But it doesn't hurt to try. And that's the issue with the NAND gate. It's gonna fail at the first test. Maybe I can put a knot here and attach this to it here. Not sure if this makes any sense, but Oh, it's because I took this off. Close, but not quite. And I guess this knot doesn't make any difference. What if I put this here? It's probably not gonna work, but yeah. Because then it's just gonna work like the AND gate. Hmm. Let's see if I can put an OR gate here. Then I'll need the none or the NOR. Yeah, but that doesn't make sense. Maybe if I put an AND gate here. I'm not sure if I can do this. Yeah, that's the issue. have to turn this off somehow. Yes, same problem. Doesn't work. I think I'll take a break and then, yeah, refresh my mind, then come back later, probably. Try to do this. But I'm definitely not gonna look at the solution or anything. I think I'm just gonna keep trying. Unless I spend like more than 10 hours trying to stuck on this, then I'll probably research on how to do this. But I think it's better to just keep trying and failing because I'm getting more used to the logic of how each gate works. And that's the point. So yeah. Not sure if I'm gonna come back today, maybe today or tomorrow, and keep trying to do this. So see you.